All right, hello all. I told a couple of you guys that I would record the stuff that we put on our note card, so that's what we're going to do. It's not going to be too terribly long of a video. And so this is just formulas that you will need that I will let you have for the test, which I'm hoping to take tomorrow. I don't know. It's just been a mess of a week with everybody gone. So yeah. All right, law of sines. Let's start there with that one. This one is probably the one that you have memorized. Sine A over A and sine B over B. You guys probably have that memorized, maybe, but we'll write it down anyway. Sine A over A, sine B over B. Okay. And then the law of cosines is a little bit different. Do you guys know what the law of cosines is? Do you have it memorized? Do you remember it?
C
squared
equals A squared plus B squared minus 2AB cosine
capital C. Good for you. Look at that. Okay, in the other class, we also wrote down the other two formulas with like the letters switched around. Okay, so I'm going to write down those other two. If you don't want them on your note card, don't write them down. Okay, I'm going to write them in a different color. So if you are particular about like which one is A, which one is B, which one is C, and it's really confusing if you switch them around, some people like to have like B squared equals A squared plus C squared minus 2AC cosine of capital B. That's the other formula, right? It's just the same thing but switched around with different letters, okay? Also, you can do A squared equals B squared plus C squared minus 2BC cosine of A. So it just depends on what you're given to start with, but keep in mind that all three of those formulas say exactly the same thing. It's just like whatever you're given, okay? So if you're given A, like angle A, all you have to do is just take that equation and switch it around so that like the A is in the correct spot or whatever. So you wouldn't necessarily need to write the last two formulas down. Some people wanted to, so I put them up there as well. But just keep in mind that they're all the same formula. It's just whatever you're given to start with. Okay, so if you want to write all three of them down, you can. Okay. Other things that we wrote down was, in general, when do you use the law of sines and law of cosines?
Law of sines is when you have two.
Okay, so looking at this, I have capital A and capital B. That tells me I have two angles, right? So I'm going to put a star here, two angles. And I have lowercase a, lowercase b, which tells me I have two sides that are also involved. Now, keeping in mind that of those four things, one of them I'm solving for. So I might be solving for little b, but that still involves side b, right? Okay, so two angles, two sides, one of those things, one of those four things I will be solving for, okay? What about law of cosines? If I just look through the formula, I have a lowercase c, a lowercase a, a lowercase b. That tells me three sides, okay? But I only have one capital letter, which means I only have one angle that I'm looking at. Now, again, one of these four things I will be solving for, whether it's the angle or the side, but that's what I have going on there, okay? Now, law of sines and law of cosines, when do you use either one of those? Like, when do you use the law of sines and the law of cosines? Has to do with triangles, but in particular, what kind of triangles? In particular, what kind of triangles use this law of sines and law of cosines? Not right triangles, the ugly ones, right? So this is for non-right triangles, the ugly ones, right? Now, I did tell them first period that, did you know, you can actually use the law of sines and law of cosines for right triangles, right? Like for triangles that are right triangles. But I'm going to flip over to the other side of there's one more thing I want to write down on this side, but flip over to the other side of your note card, and we're going to write down some stuff on this side. What can you use if it is a right triangle? That's easier. Pythagorean theorem, okay. So we'll talk, okay, so I'm going to split this up into like three things on the bottom, two things on the top. So we have Pythagorean theorem, and these are for right triangles. Pythagorean theorem, a squared plus b squared equals c squared. I don't know if you really need an example of that, but a squared, b squared, c squared, that's for a right triangle. What else can you do? Like as far as angles go. Yeah, SOHCAHTOA. So SOHCAHTOA. You can use SOHCAHTOA when you're dealing with a right triangle and angles and stuff. Okay. So just FYI, I'm going to zoom out. You can use the law of sines and the law of cosines when you have right triangles. You can use those things, but you can't use SOHCAHTOA when you're dealing with non-right triangles. Does that make sense? Okay. And really, SOHCAHTOA is the easier method than using law of cosines and law of sines for right triangles. There we go. Okay. So, do you want to do an example of a SOHCAHTOA problem? I think this morning I did like something like this. Here's my angle. This was like 23 degrees. I said X and 8. I don't know. So this is a SOHCAHTOA problem, right? If I'm solving for X, I can do that. So, 23 is my angle. We have 8 and X. Which trig function would we use if we have 8 and X? Which one?
Yeah.
Yep, tangent. 8 is the opposite, X is the adjacent. Okay, and so we would do tangent of 23, and that's equal, would it be 8 over X or X over 8?
8 over 8.
8 over X. O comes before A, so 8 over X. Now, what happens when X is in the bottom there?
Just
You switch those two places. So X equals 8 over tangent 23. So if you need an example, you can write that one down. And then we ended up getting like X equals, I don't remember. 8. All my calculator people are gone. Usually it's Erica or Haley. Ha!
It used to be.
It used to be you. Sometimes you do.
Till I gave up.
18.8 is what X is, ish. Okay. So you can use SOHCAHTOA when it's a right triangle. You can also use the Pythagorean theorem when it's a right triangle. Okay. Let's go back up here. One more thing I want to add to the law of sines and law of cosines on the back side of your unit circle is that if you are, like, let's say you're doing law of sines, right? And you're solving for B. You just do the straight, like, cross, multiply, divide, good stuff, right? But what if you're solving for, like, capital B? If you're solving for an angle, you'll have to at some point use the inverse, right? Okay. So same thing down here. If you're solving for, like, angle C, you'll figure out all your stuff, unwind it, get cosine of C by itself, and then at some point you'll have to use the inverse. So I'm going to put a star down here that says when finding angles, if you're solving for the capital letters or when you're finding the angles, you will at some point need to use the inverse. You must use inverse sine or inverse cosine somewhere at some point. Usually it's your last step. Okay, it's the last step before you solve the problem. You will have to use one of those somewhere. Okay, and then it's always a really good idea to go back through your answer and like just see if that seems appropriate, right? Like if you get an angle that's like less than 1 degree, you probably didn't move a decimal right or something, you know, so be careful of that. Okay, 3 more things that I want to add to the bottom here, and one of them is, do we remember how to do the geometric mean back from section 8.1, which was like 30 years ago?
X over whatever.
Yeah. Okay, we do remember how to do it. So I'm going to do a geometric mean of, like this morning we did 5 and 12. Okay. If I would just do the straight mean of 5 and 12, like the average of 5 and 12, I would get 8.5, right? So I'm going to keep that in mind. Like, I'm going to write that down here. Don't write this on your note card. So the geometric mean of 8 and 12, I'm going to put that down here in the yellow if you can see that, is, or of 5 and 12 is 8.5. That's the actual average. Okay, but geometric mean is different than that. So what this is meaning is that like x over 5 equals 12 over x, okay? And we cross multiply. So we get x squared equals 5 times 12 is 60, and we take the square root. So x is actually, I think it's like 7.7 or something like that. I don't know. I got to figure it out. 7.7, yeah. So geometric mean, like we got 7.7 versus 8.5. Way different. Geometric mean is way different. Now, Chase was asking me this morning about geometric mean, and he's like, well, like, when do we use geometric mean? Okay, so I'm going to draw a picture here, and I'm going to erase it, so don't draw it. But, like, do you remember when we did, like, our small triangle and our medium triangle and our large triangle?
Yep.
We would a lot of times end up doing geometric mean when they would do, like, 5 here, and x is here, and x is here, and 5 is here, or, and 12 is here, or whatever, you know, like, and then we would set up a proportion, which would look almost exactly like this. and do a geometric mean of 5 and 12. So that's what a lot of times will happen when you have those small, medium, large triangles, is you'll end up doing the geometric mean by setting up a proportion. So that's when that will show up, okay? All right, let's, in this box over here, put, I gotta erase some stuff that we don't need. In this box, let's put a 30, 60, 90 triangle and a 45, 45, 90 triangle in here. And we're going to label these guys like that. There's my 30, 60, 90, 45, 45, 90. And we'll give you all of this stuff so that you can look back on this. Okay. I'm going to say that my 60-degree angle is the bottom one, 30 is the top one. This one's 45 for each one. Okay, and we know from this section that whenever you have a 30, 60, 90, or 45, 45, 90, the sides of your triangle will always have a certain relationship to each other. Okay, so do you remember the side relationship-y things for a 30, 60, 90?
Bottom is 1.
Bottom is 1.
Hypotenuse is 2.
Yep.
And long side is square root of 3.
Yep, and the long side is square root of 3. Okay, so, like, for example, if I gave you a triangle that said something like, let's say this was 7, what would the other two be?
14 and 7 square.
Yeah, and 7 square root of 3. That's exactly right. Okay. Or if I gave you something like, let's say this guy is 10 square roots of 3. What would those two ones be?
Bottom is 10, and that one's 20.
Yeah, so they'll just always have that relationship between each other, okay? What about a 45, 45, 90 triangle?
1, 1 square root of 2.
1, 1 square root of 2. Okay, now I'm going to give you an easy one, and then I'll give you a hard one, okay? Let's say, here's my triangle. Let's say this is 6. 6 and 6 square roots of 2, right? Okay, now let's do another hard one. Let's say that this guy is 5 square roots of 2.
That's 10.
She's so smart. So smart. So how did you get from here to here?
Multiply by square.
You multiply by the square root of 2. Okay, square root of 2 times square root of 2 is just 2. So this is 5 times 2, which is 10. And then the bottom would, of course, be 5 square roots of 2. Confusion? Not too bad? Okay. All right, so that was super fast. I thought I was going to trick you, and I didn't. Okay. So if you're watching this video and that didn't make sense to you, kind of like go through that a little bit slower again. And the one other thing, I forget what I put in the bottom right corner. Oh, area. When I ask you for area of a triangle that is like a gross one. Area. Okay. The formula for area is that 1/2 BC sine of A. Do you remember that? We use the sine formula for finding area. Okay, and the thing to notice is that this formula has 2 sides that are involved and 1 angle that's involved. So here's my angle, okay, and this is the angle that they give to us. But the important thing to know is not like what they're called, but that these 2 sides are the ones that touch the angle. They're adjacent to the angle. So I'll give you an example of this. Okay, and I'll give you one that's not labeled with A in the right spot. Okay, so let's say we'll go A, B, C, and we'll say that this is 63 degrees. We'll say this is 11, and we'll say this is 13 feet and feet. Okay, now I do not have angle A, but that's the way my formula is set up. Ha! Shoot, I'm stuck. The only angle that we have is 63, right? But it doesn't really matter what it's called. We just know that 63 has to go in this spot because that's the only angle that I have, right? But then these two, if these two, doesn't matter what they're called, those two just have to be the sides that touch my angle. Those are just going to be my 13 and 11, right? Okay, so it doesn't really matter. I just know that the 2 sides that I have here have to be my 11 and my 13, and then I have sine of 63. And then I just plug it all in and figure out what that area is. I'll do it just so you have an answer if you're writing this example down. I'm going to use 0.5 instead of 1/2 when I type it in because it's just easier that way. Cosine 63. And I get for an answer for an area is 63.7, and that's feet squared. So something in that nature. So just be careful when you're looking at the formula. It doesn't necessarily mean, like, kind of like when we do the law of cosines on the front side. Like, it doesn't matter what your things are called, just as long as they're in the right place. Like, you know, the two sides are touching the angle and etc. Right? Anything else that we... I'll let you finish writing for a second. Okay, let me go back up to the one that we did up above here this morning. We wrote all of those things down. One thing that we added to the law of or law of sines. You know, you can use the law of sines versus the law of cosines when you have a group. You know what I'm talking about? Like you have A and A together, or you have B and B together, or you have C and C together. We wrote that down on our note card on the front side or whatever. So if that's beneficial for you to write down, go ahead and add that to your law of sines area. If you know that and you don't care, you don't have to add it. But you have a group, like when we were listing A, capital B, capital C, lowercase a, lowercase b, lowercase c. If you know like the A's, or you know the B's, or you know the C's, then you know that you can use the law of sines to solve it, okay? Versus law of cosines, when you do that, you won't have any of them mismatched. You'll like know A, and you'll know B, and you'll know C. Like you won't know any of the groupings together, okay? Those will be the information that you're given. So anyway, that's how that works. Let's see, anything else that we have down here? I don't think that's maybe it. That might be it. In fact, we didn't even write down this morning. We didn't write down the Pythagorean theorem, which is okay. But anyway, okay, good. That's all I have for a note card. That's a lot of stuff, I guess, but anyway. Okay, anything else we need to add before I close this video out? Nope. Okay. All right, bye people in the video.